Hello, my name is Jason Chanko. I'm an applications engineer for Rigol Technologies USA, and I'm going to present the DS6000 series of oscilloscopes. This particular model that we have in front of us is the DS6104. The 6104 is a 1 gigahertz scope capable of 5 gigasamples per second sample rate, and then it has 4 channels, so that the 6104 denotes the 1 gigahertz, and then 4 denotes the number of channels that we have available to us. With this particular, or in this particular demo, I've connected channel 1 and channel 2 to the probe compensation point on the right-hand side of the front panel. That's delivering a 3-volt peak-to-peak signal at 1 kilohertz, 50% duty cycle, and it is a square wave. I'd like to describe a little bit more detail about what we see on the screen for the DS6000. On the lower left-hand corner, what we have denoted are the channels, their voltage settings. We have a quick menu on the left-hand side that is horizontal as well as vertical measurements. We have the auto trigger. This is actually denoting when the instrument is triggered, and also the trigger mode that we may have enabled. When it says auto and the green light is flashing, that means that we're just doing a rolling trigger. Once we've collected a certain amount of data in the memory, it starts back over again. It's not looking for any particular trigger event in order to update the display in this mode. Then we have a small h, which stands for horizontal, and then the number of seconds per division in the horizontal scale. So we have 1 microsecond per division. There are 14 divisions across the display in a horizontal frame, and so we have 14 microseconds from left to right on the display. Just to the left of that, just to the right of that, we have the sample rate. In this case, it's 5 gigasamples per second, and then the number of data points that we're currently collecting per waveform, and that's set to 70,000 points. Then we also have this squiggly line. The squiggly line denotes all of the waveform that is currently being collected in memory. That small orange badge with the T in the center denotes the trigger point. If we go over to the horizontal position, we can move that trigger with respect to time, and you can see that we're then moving in the waveform as well as on the main display. The display, we could describe the display, this would be the entire memory location, and what we're seeing on the display is a small window of that, and as we take that window we can move it through time along the waveform. You can imagine the waveform, if we had an infinite display on either side, would continue on, and we would be able to move that window back and forth both horizontally and vertically. The D denotes the distance in time from the trigger point to the actual center point of the display. So you can see as we go counterclockwise, we're actually going in negative time, what's called pre-trigger area. And if we go the other way, we're going to post-trigger time. Again, this is the trigger, so these are events that have happened after the trigger. And so we'll see we have a positive time-based offset. To get back to center, you can actually just press the small position knob and it will bring it back into the center point. Then we'll go on a little bit further. We have T, which stands for trigger. And now we see that in yellow, we have an upward arrow, channel 1, and then we have 0 volts. What that's saying is that we're triggering on channel 1, we're triggering on an edge trigger in the upward direction, so we're a rising edge trigger, and the current trigger value is set to 0 volts. If we were to adjust that, you can see we can go in the positive direction, and we can go in the negative direction. And if we selected another channel, this would then denote we were on that particular channel that we were interested in. So now that we have a little bit better idea what we're seeing on the display, what I'd like to do, show you a neat feature that we have. It's the auto key, and I'm just going to press it. Give it a second. And now what you'll see are 2 waveforms on the screen. The 2 waveforms that we're seeing are channel 1 and channel 2. Again, they're connected to this 1 kilohertz signal coming in. Oops, making a little noise. They're connected to this 1 kilohertz signal on the right-hand side here, and then we're displaying both of them. I'm just going to select, we can select small sets of waveforms, large set of waveforms. That's really just the number of periods that we're seeing on the display. And then we can go to a rising edge or falling edge, and that's just going to select one of the rising edges or one of the falling edges in order to do more of an analysis. What I'm going to select is actually just a smaller set. And now you'll see that we have channel 2 highlighted, and it's also brought up automatically 2 readings for the period and the frequency of channel 2. Remember, I said that channel 2 was connected to that probe compensation point, and that is a 1 kilohertz signal, and you can see here we are reading 1 kilohertz as our frequency readback. So, next what I would like to do, I'm going to disable channel 2 briefly, And we're just going to focus, and again, to disable, we just double press that key. So we're going to focus in on channel 1. To get the menu to slide back, I press the menu key. And I'm going to then bring down channel 1. So I want to select it, and then bring that down using the vertical position. You can also press the 0, and that will take that vertical waveform that you have controlled under here. You can see we've highlighted channel 1, so now we're controlling channel 1, and we can move that in vertical space. But if we want to bring it back to 0, we can just press the small knob. And what I mean by bringing it back to 0 is we're actually bringing the 0 volts line into the center of the display. So in this case, it's going from 0 volts to 3 volts peak to peak. So we have 1, 2, 3 volts. Again, 1 volt per division vertically. And now I'd like to highlight the zoom mode. To get into the zoom mode, what you can do is, here's the horizontal scale button. If we press that in, now we'll get the split screen display. On the top we have the full waveform, and on the bottom we have a zoomed waveform. And you can see now it says zoom 100 microseconds. Remember that top scale was 200 microseconds per division. Here what we can do is we're now in control of the bottommost screen. You'll see the window starts to shrink, so now the visible area that we have here is denoted by this black box on the top. And we can slowly make that larger, smaller scale, so we're basically zooming in on this area of the display, or this original waveform that we have. You can imagine if we had a very long waveform, or we had lots of information that we were sifting through, this would be nice to be able to zoom in on a particular area. And now we can check that rising edge. We can look at the leading edge of that particular pulse in a lot more detail. Now I'd like to show off some of the measurement capabilities that we have with the DS6000 series. I'm going to start by going back to factory defaults. Factory defaults are very easy to get to on the oscilloscope. You simply press the save button and you'll see the factory key. By pressing factory, we'll go back to factory defaults. It'll clear all of our settings. If you ever get into a situation where things get a little bit confusing, you can always start back from the factory defaults. It's a nice way to kind of get back to ground zero and then start doing your adjustments at that point. So I'm going to press auto again and get back to where we originally were. And we're going to get back to the single measurement. And you can see down here that our channel 2 is actually highlighted. What I'd like to do is pick up I'd like to do some controlling and manipulation and measurements on channel 1. So I'm just going to press the channel 1 key, and you'll notice now channel 1 has been highlighted. And now the channel 1 menu has also popped out to give us some options available for the channel 1 settings. And we can take a look through those if you'd like. But what I really like to highlight is some of the menu keys or some of the quick measurements that we have. If we press this menu key on the left hand side, you'll see it says vertical currently. If we pull that out, now we have all of the vertical measurements that are that we have at our fingertips. We have max, min, peak to peak, top, V base, V amplitude, and V average. If we down arrow, you can also see we have VRMS, overshoot, and pre-shoot. So let's just push Vmax, so you can see now we have the Vmax value has come up. If we press the menu key again, we'll see the horizontal menu will come up, and we can select period. Again, here's the period, here's frequency. And let's say we wanted to do some more with our measurements. In the menu over on the right hand side, we can see that the measurements, which is again, measurements are located in this area. We can select which channel we're going to be working with. We can display all, and that will display all for that channel. And we can also select channel 2, and now we'll have all of that data as well. Starts to get pretty filled with data if you'd like, and then very easily we can do display all off and it will clear it. We can also clear all of the items here by selecting delete all, and we're all set. And we can also do some other things with measurements and cursors. If we come over here to the cursor area in the menu, pull cursors, and we have a few different modes. We have manual, tracking, and auto. If we have a value pulled up, a measurement pulled up over here, and we hit auto, it will actually give us the area frequency parameters. See how it says measurement parameters frequency? And now it's indicating where it's making those frequency measurements. And it's been highlighted, which is really nice. We can actually select if we had a number of parameters. Let's go to vertical and we'll do VPP. And so now we can select between the different values that we have available, and the cursors will then indicate where we're making those measurements, which can be extremely helpful when you're doing some really quick measurements on a time-varying scale. If we were changing this particular waveform, let me do a little manipulation, and you can see that that it's actually, I'm just pulling the probe off of the probe compensation point, and it shows that the cursors are now dropping down and telling us what our new measurements are. So use that to automatically perform the measurements and also indicate where the scope is making the measurements. And I'm just going to disable those.